Lizzie.
All right. Thanks, everyone, for coming today. We appreciate it. As usual, we're just going to do our short introduction and Fierce commercial, and then we'll kick it off to the smart guy in the room. So Fierce, we are a small woman-owned business specializing in enterprise open source technology. So you can see on the right here some of the main vendors that we focus on and work with. You know, part of the value add that we consider part of our value-added reseller name is we put on events such as this. You know, obviously supporting Ansible is part of our Red Hat practice. And then we also put on customized workshops for our customers depending on what kind of technology they're looking to focus on. We've done them for individual vendors. We can also combine vendors, and we really tailor those workshops specifically to what that customer or that team is looking to accomplish. So yeah, that's just my really short commercial about who Fierce is and why the heck we sponsor Ansible Nova. But I wanted to give a short intro to Kevin. I usually don't do this, but Kevin has been an Ansible Nova member for as long as I think I've been at Fierce. I don't think I've ever not seen him at an Ansible Nova. So Kevin, we really appreciate your support, and I think it's super cool that we have a member of the community presenting today. We normally have someone from one of our vendors come in and give a presentation, but I think it's really awesome that Kevin's going to come in and give his experience, because as a member of the community, he knows exactly what people want to hear. So I won't give too much more of a commercial for Kevin. I'll let him do that himself. But just wanted to give him a short intro. So Kevin, I'm going to stop sharing my screen, and then you can go ahead and share yours.
Okay, before clicking on the camera, I just want to let everybody know I created a presentation apparently so epic that it blew my computer, so I'm operating on Kai Asriel, another member's computer today.
Hi.
So I'm operating a device I'm not exactly familiar with. There we are. And I will begin sharing now. And there it is.
No, I got it.
Okay.
There we go.
There we go. Okay. Okay, everyone. Well, welcome to my presentation. This is a place for everything and everything in its place. I am your host today, Kevin Latchford, CCNA and CCM. I am the main guy of Nova IT Guy. But first, introductions, a little bit more about myself. I'm the main guy at Nova IT Guy, my own firm, which is a managed service provider operating out of Northern Virginia. Personally, I'm a child of the Bell system. Telecommunications is in my blood from both my maternal and paternal side, and which is where I started. I started out in telecommunications with a mobile satellite provider, and then after that, I moved into industrial Internet of Things before returning for a time under a number of companies doing AT&T contracts, first for the 4G network and now for the 5G, as well as working with another company some of you may know, Claro, which operates extensively in the Caribbean and Latin America. I'm a self-taught code guy in Elmer. In fact, I'm a ham radio operator, been a ham radio operator for over a decade now. Hold a general license, and give back to the community through Skywarn. I'm a storm spotter for the National Weather Service. So when there's a severe thunderstorm, you will find me out scanning the skies for anything wicked. To give you a little clue onto the photo there, that is actually me 150 feet on a cell tower just outside of San Juan, Puerto Rico. Me working on my rigging test and my climbing tests.
Hey, Kevin, we're not seeing that photo. We're seeing a place for everything in its place.
I apologize. It should.
There we go.
Well, I guess we'll just have to operate from this. Let's see if the slideshow will go again. Can you see it now?
We see it. It's not full screen. We do see the who am I.
Okay. Well, then we'll try using this. Unfortunately, this may not integrate exactly with Google Meet, but we will try our best. But to go on, I'm a professional. I'm I have a certified business analyst, a certified Scrum Master for project management. I'm also a Cisco certified network associate, and I'm certified in professional applications for Python. and have been a open source aficionado, and in fact, a Linux user for over a decade, principal operating mostly with Ubuntu, but have experience with Red Hat, CentOS, and a good bit, and going to actually move hopefully soon into Arch Linux, if all goes well. Various organizations I've been a part of, as you all know, Nova Ansible, Sterling Park Amateur Radio Club, Nova Hackers, which is actually one of the largest meetups for security professionals in Northern Virginia, as well as been a long-term member of the Northern Virginia Linux Users Group, where I started with Linux, as well as being part of the local 2600 Hacker Quarterly group, FEAR, which meets in Reston. In fact, we're meeting tomorrow night at Nova Labs in Reston, Virginia. But let's come to my company. And Nova IT Guy, when it comes to IT, I'm your guy. I founded the company in 2020. We've been in business now for over a year. And we're serving commercial clients all over Northern Virginia, from basic hardware and software support to cloud and network solutions, to even technical consulting and documentation. And we are proud to be moving in a new direction, focusing on, especially with the needs of our clients growing more every day, with us moving to the cloud, utilizing resources much better on servers, as well as more people wanting to get into DevOps, which we'll be getting into extensively today. We are moving into that. We specialize in open source solutions, so we're here to work with what you have and to provide as much as you can in a cost-effective manner. And the great thing about Nova IT Guy is, like country doctors, we come to you. We will come to your office, we will come and we will build it for you. And we no job is too small and no task is too great for us. We welcome all comers because there's nothing better than to solve your problems and to make you the best business you can with our assistance.
We're
And
still seeing the who am I slide.
I apologize. We're just going to come down to here, and unfortunately the slideshow feature is not working. So I will move over back to on the professional so you guys can see what I was just talking about.
Can I see it?
Can you guys see it?
Yep.
Okay.
Yeah, we'll use this instead.
We'll just go here. That's fine. And our most recent projects, we're actually building a small construction firm's web services, and we actually responded to and mitigated a very serious network security breach where they were actually warned by their provider because someone had actually come onto their system and was actually torrenting on it. So we closed that little loophole. And we traced actually an email scammer and a near compromise of their security recently. They had been tempted to be a mark for a group out of where we traced the link to Kolkata, India. So it seems to be one of those wire scammers was trying to get him. I designed actually a really interesting cloud-based and e-learning solution for an education startup using Moodle and WordPress, which has been, as I understand, very successful. But recently, one of our largest projects was being principal engineering contractor for a defense subcontractor who shall remain classified to build a full-scale infrastructure as a service and secure DevOps solutions for sensitive information purposes for various agencies of the U.S. government. I could give you more details, but in the immortal words of Mikuru Asahina, that's classified. So unfortunately, I can't tell you much more than that.
Yes.
But that's not why you called. We're here for something bigger. A place for everything and everything in its place. There's no one-shots, but why? Well, there's no one-shot solution for everything yet. There are several who do come close, and we'll go over these. But no one-size-fits-all exists yet. And every tool actually, though, does have something they do well, from Jenkins to Docker to Zabbix, which we will go over naturally. And DevOps concentrates extensively on open source. And many of these tools you can actually use for free, so giving you a great cost savings to your business. And the video question has dropped. So I apologize. Because of the many advantages that we have, is why would we use it? Well, because there's many advantages of using many of these tools. You can use a single methodology regardless of its end installation. You can use the same commands in for different uses and results. And we're going to especially see that when we get to containers, discussing specifically Docker. And maximizing your potential by combining different tools to achieve similar ends, tailored to those exact needs. And we'll see that extensively with CI/CD pipelines, but we'll also see that with our monitoring solutions as well. So are we losing opportunity for not using them? Yes. We're quite frankly we're not using a greater cost-effective potential by not utilizing as many tools, being that many of us are going to proprietary ones, which come at a cost and may not be exactly fitting your requirements, whereas these could fit like a glove. Now, I'd like to kind of crush some of your expectations in that this is not an exhaustive list of DevOps tools. There are many others out there. So our goal here is to more explore the concept and go from there. Now, first of all, we can't talk about DevOps without talking about Git, the source of truth for many of us, and it's becoming more and more the source of truth, period, in DevOps. But there are many kinds of Git. First, you have the original Git, and this is a Git you would probably have on premises. Some put them on clouds, some put them on remote locations, but most of the time it's going to be a server sitting under your desk, in your tech closet, where have you. And although you do have a lot of cloud options, why would you want it? Well, it's behind the wall in security. You can put it behind your own firewalls, kind of keep everything private. And especially if you have a lot of trade secrets, in what you're building, this is a great way to secure it. And it's yours, and so is your code. So that you can own your code for as long as you wish to keep it so private. If you wish to put it up on the cloud, that's your choice. You want to keep your cards close to your chest, you can do that too. And surprisingly, it's not very difficult to set up. There are various virtual machines, container instances, and other kinds that you can use to affect whatever you need and whatever equipment you have on hand. Now, of course, if you're not so concerned, or your company has desires for its own public page, well, you can go to GitHub, which is the most well-known repository for Git, and for code collaboration amongst many employees operating all over. It's probably the best one you can get because its collaboration elements are exceptional, even better than what we'll discuss in a minute, being GitLab, in my experience. And once again, for companies, they can actually have their own section of GitHub that is theirs, and they can make stuff behind the access wall, as well as repositories that are open to the public. So you have a lot of flexibility there for whatever you like. But the most interesting of them all is GitLabs, especially GitLabs 14, which promises to be a pure GitOps CI/CD, which is continuous integration and continuous delivery, as well as continued deployment, for your code. So literally, you can put a code commit into GitLabs, and you will have at the other end a fully built image ready for whatever production environment, whether it be on-premise or cloud. And it is GitOps, the principle of using Git as your only source of truth for your DevOps pipelines and developments in the most literal sense of the word. However, it works as a kind of, you follow their methodology. So if you like to develop your pipelines a certain way, you may benefit from our next subject, which is the CI/CD pipelines. Now, the old reliable, many of us all know, is Jenkins, utilizing a traditional methodology that was not exactly Kubernetes. It's not exactly, up until recently, Kubernetes ready. That has since changed as Jenkins has joined the Continuous Deployment Foundation, and there's been a lot of things that have changed, but it's still under the hood. It's the same old Jenkins we've all known. And it's still very useful. And the main reason why it's very useful is its adaptability by plugins. It has lots of plugins for many things you'd like to use, from the testing elements using Selenium to its connections to not only your own Git server, but also GitHub and GitLabs, as well as its inclusion in a number of solutions, which we'll discuss later. But one of the biggest plugins that has recently come on the scene that everybody should probably be aware of is JSAC, which is Jenkins configuration as code. So you can actually bring the declarative language that you use in other aspects of your GitOps pipeline and bring it to Jenkins, thereby making it human readable and very simple to do, far simpler than Jenkins used to be. But for cloud native, right now the largest one out there is Tekton. It's cloud native, and it's very flexible to be able to be tailored to exactly how you wish to deploy your solutions, which are predominantly Kubernetes clusters, but containers of any kind are perfectly suitable to a Tekton pipeline. But the one thing you can be guaranteed with Tekton is if you build in there, it is built to the best practices for cloud as far as its security and networking features, as well as its redundancy. But that's not the only CI/CD. Improvements to Jenkins actually came to making it more cloud native, resulted in a variant of it known as Jenkins X. And Jenkins X is very interesting in that it is built in GitOps. So you can almost get the same kind of features you get from GitLabs, but on your own on-premises server. It plays very well with Tekton and can actually automate Tekton pipelines, which are known to be somewhat difficult for those who are not as skilled in using it. But another advantage is that it gives you feedback on pulls and issues as it pulls from your Git repository, as well as issues in testing. So you'll know the minute in the pipeline something went wrong or something is an issue, you'll know immediately. And it can give it to you on your favorite, such as PagerDuty or Slack. One other great advantage of it is also its preview environments, which is really great because you can actually see your code kind of running in a safe, secure little virtualized space. So no surprises once you get it out into deployment. And as I say, it's good for private cloud. It's very good for your on-prem or for another cloud solution, which we'll discuss later for on-premises. It's really good for that, and it's optimized for that. But if you like to use public cloud services, well, then Spinnaker might be for you. Not only does it use role-based access controls, which is very similar to your, like such as IAM on AWS. So you have role-based access control, so only those who have certain clearances have access to that certain area. So you can kind of separate out your senior engineering from your junior engineers to your interns. And that can be a great result, kind of keeping everybody kind of separated and no chances of breaches or people having access they shouldn't. And it follows that principle of least privilege, which is, from every security expert I speak to, a major thing we need to do more of in this industry. Event notifications is very similar to what you get with Jenkins X. However, the one element of it is that it tells you everything that's going on. It doesn't tell you when things are going wrong. It also tells you, well, what status are we at? So you can know exactly when your app deployed. When did it go through the testing? So you can have it for your own informational purposes, which is a nice thing to have when you're tracking your deployments. And also it can go utilizing various deployment strategies. Everything from canary to rollout to rolling deployments to replication, and even blue-green or black-red. It supports actually both of them. And even more interesting is the fact that if you're still using a lot of VM images on your cloud services, This is great because it actually can create its own virtual machine images from the code you created in addition to container and Kubernetes clusters. As I said earlier, it's very much optimized for the public cloud, and it works with all of them. But it does have an ability to work with your own on-prem equipment, especially if you like to use on-prem for development and on the cloud for your production. And now that brings us to containers. Docker is the most interesting for most of us because we still use it extensively. It's the first container system many of us even used. And although Kubernetes has recently dropped its support for it, it still has a lot it can offer. One of them is for a more or less original intended purpose, which was for a lightweight independent virtualization method, allowing you to achieve what became microservices, but also allowing you to segment your processes of your application. And you can still cluster on its own using Swarm, which we'll show actually an example of later. So it's a great replacement for VMs in confined deployments, especially when you want to use small form factor devices because your server room is crowded, but you want to be able to get that capability in a smaller space, less resources. Docker will get you there. But in response to Kubernetes dropping Docker support, there's been a great requirement for something to replace it. Docker was ubiquitous to Kubernetes until recently. Well, one of the greatest out there is Podman. It's a daemonless container that allows you to be rootful or rootless, as Kubernetes now requires. But also, its customization allows you to put whatever functions you need. So it's lean and mean and only contains whatever is needed to run the machine. And as I said, it's Kubernetes compatible. So for those of you using Docker and you need to move up to the latest version of Kubernetes, which doesn't have the support, Podman will be your friend. But one thing should be noted here, Docker or Podman, the commands are the same. In fact, you can alias your command line to actually, every time you put in a Docker command, it's going to build a Podman container. And this is really good because you'll be able to utilize your same skills. You don't have to reinvent the wheel and relearn how to make that wheel. You can use whatever you use with Docker, you can use with Podman. And that brings us to the discussion of clustering. And there are many ways to do it, but the most common is the original Google, the OG, which is Kubernetes. Very good for both on-prem and cloud, but on the cloud it has a distinct advantage in that most cloud service providers have special sections of the cloud that are dedicated to running Kubernetes, such as AWS EKS, and it integrates well with cloud functions such as Lambda, Kinesis, and Aurora for databases. If you need some extra management, no problem. Just use Rancher. It'll get you there. It'll take all those extra, it'll add a few extra bells and whistles to improve your Kubernetes on the premises, but make him just as good as you get in the cloud with those specialized services. But for many companies, they're looking to continue that Docker support, and they want more security, a better GUI, and other such things. And that's where OpenShift comes in, which is basically, as someone described it to me, it's Kubernetes Red Hat style. One reason why many people are using Kubernetes is its Docker support. When Kubernetes dropped it, many people moved to OpenShift because OpenShift stated that they would keep up Docker support. So for legacy apps, you might want to consider OpenShift if moving from Docker would be difficult. The other advantage is its full-fledged role-based access control. It gets very granular and it's very strict. In fact, the Docker support that it does have does not have the security defects that vanilla Docker does when it was working with Kubernetes. In other words, it works rootlessly and doesn't have the troublesome connections that are such a security concern that caused Kubernetes to drop it in the first place. And if you're building in and you want to have something that basically brings your Kubernetes from start to finish? Well, just know that it has its own integrated CI/CD system, which can be heavily automated using a tool we'll discuss later, i.e. Ansible, and mainly because there's Jenkins inside. Now, I put that in quotes mainly because it is Jenkins, but I like to say it's Jenkins wearing a red fedora. It's kind of a Red Hat optimized method of Jenkins, but you can run regular Jenkins in it if you wish. There is integration with the Jenkins application, but using Redshift's own derivative is quite impressive, I must say. And that brings us to the next element of cloud computing, that being infrastructure as code. And you had, up until recently, only really one option, the original being Terraform, utilizing writing it in HCL, which is HashiCorp's unique configuration language, with also support for JSON. However, there is increasing YAML support. So for those of you who are used to building YAML for your OpenShift or Ansible, you can use something very similar, very declarative YAML scripts on it. It is right now just a plugin, but support is growing day by day. But what's the advantage of Terraform? It's simple, it's quick, it's efficient. Simple human-readable scripts build your infrastructure at a stroke of a key. And it's great for builds that don't have extensive conditionals. No if this, then that. However, if you do need that, you might want to work with Pulumi, which allows you to use the programming languages most of us use, some of them being Python, Go, Node, and many others, which allows for more customization and adaptability. So you don't have to watch it as much as you might want to have to watch a Terraform infrastructure. You have less hands-on, and it will do most of the work for you. And this is really good, though, for builds that require extensive objects, conditionals, and especially variables. A case of if this, then that. If this system goes down or this system, encounters a heavier load, this will basically modify the environment to suit the need. Another aspect of this, of DevOps, that obviously must go without saying is your syslogging and your monitoring. Now, as far as logging, you had up until recently many people use Splunk, but now we're seeing the increase of what we knew as ELK, but is now a unified system known as Elastic. ELK standing, of course, for Elasticsearch, Logstash, and Kibana. Kibana being your visualization, Elasticsearch being your search engine, and Logstash being your logging tool. But recently there's another one, and that being Grafana, which is a very metric-centric visualization tool, which really outstrips Kibana in the visualization category. But they both have a unique thing that they can bring to the party. One thing about Elasticsearch is it's a trusted syslog application, something that really gave Splunk a run for the money and still does. And its embedded search engine is really great if you have to deal with if you have a large setup with a ton of data coming in at any one time. But Grafana's metric-centric methodology makes it best suited for real-time monitoring. So you can see the most minute aspects of everything that's going on in your processes. And one of its most known pairings is with the monitoring application known as Prometheus for sensing, which we should get to now. Prometheus is one of the greatest monitoring apps for, especially if you're working with Docker or Kubernetes. It has a native integration, but also because of its onboard database storage, you don't have to play around with Postgres and MySQL databases. It pretty much will store the data for you. And as I said, it works with Grafana for visualization. So it's really great for seeing things as they go and getting down to the most minute details of a continual operation. But it doesn't have alarming and alerting features. That is where Zabbix comes in. And it's great for that. But one thing also Zabbix does really well is that it's optimized for network and systems infrastructure. And in DevOps, we often talk about the application, but we don't often think about the physical servers, the switches and routers that carry us between the cloud or our customer from our solution. But Zabbix can do that, and it works with everybody, from Cisco to Juniper to even more obscure brands like Ruckus and Brocade. So you have something that basically will provide you, no matter what equipment you're using, you'll be able to know if it's working, if something went wrong. And especially in the case of physical infrastructure, if any switch or router or server goes down, it's Houston, we have a problem. You'll know the minute it has, and you'll be able to remediate it. But it doesn't have its own database, so it uses Logstash to basically serve as its database, which is part of the Elastic Stack. And using Kibana, you can visualize those logs for historical analysis. But that brings us finally to our presentation medium, which is the cloud. And we have many kinds. We have many services from Amazon to Azure to Google Cloud Platform to DigitalOcean to Cloud Foundry, tons to choose from. And they're simple and secure. But I say mostly because there are still instances of cloud breaches, most recent one being large scale, being in January of 2020 when GhostNet hacked all three of the major service providers and even got into the government clouds, I'm sad to say. But the managed services they offer can be of great value addition to your company, and they take care of most of the functions. So if you don't have a very large IT department, or you prefer your IT department to be more hands-off on the production end, you might want to consider public cloud. But if you use them a lot, the cost can add up, and the cost effectiveness of the cloud becomes less and less. At that point, you might want to consider OpenStack. Now, OpenStack comes in many different flavors from its various distributors, Canonical and Red Hat being some of the largest. It's customizable and private. And the greatest aspect for those of you who have data lakes and data center colo rentals, you can utilize your current infrastructure in a new way. You can basically take some of your older equipment and use it for development servers, or you can actually make it a production system in and of itself. And the greatest advantage is it's yours, and you can make it as secure as you wish it to be. Now, a particular note, what I mean is you can utilize such things as worm drives. And with the rise of ransomware attacks being ever more present every day, worm drives, not susceptible to those attacks. It's kind of like Gandalf the Grey. When it sees ransomware, a worm drive basically says, you have no power here. And you don't. And the other advantage of it is if you do get hit, you have your own monitoring system to let you know immediately. And you can handle it that way. Whereas Amazon and Azure do respond very quickly, but it depends. If they have a whole system-wide attack, they are large attack services, you may not be gotten to in time. So with OpenStack, you can have more peace of mind. And if you wish to lock it up like Fort Knox using Fortinet and Palo Alto, well, that's your choice. And you have the ability to utilize it. You do have that ability with virtual units on AWS and Azure, but here you can actually use the physical appliances, which in many cases carry more features, and in my experience, tend to be more secure. So we have all these tools. So what to do with them? Best way to use them? Well, let's go through a couple of scenarios here. One would be a great example is what I talked about earlier. You have a legacy deployment using Dockers, and Kubernetes has dropped it. Now, you're willing to return to Kubernetes in the future, but you don't want to lose your current skill set, and you want to use those Docker containers until they reach the end of their useful life. Well, what to do? Well, you could use OpenShift, have it for Docker support. But remember, OpenShift has that native ability, because Podman was extensively developed by Red Hat, to use Podman in your future builds. But you can use them interchangeably. So OpenShift, one shot, two birds. Moving along, what about if I have an on-premises app for development, but I deploy on multiple clouds when it's ready? Well, no problem. Jenkins itself would be already the best thing for an on-premises deployment, but Spinnaker also plays well with it. And you can use it to deploy using its native integrations on every cloud. So let's say you have several kinds, and we'll go off a few. How about AWS, DigitalOcean, and Cloud Foundry, for example? Spinnaker works with all of them. So what you build on that Jenkins on your own system is identical to what you get on Spinnaker. And you can program it to say, as soon as you've accepted it on your on-premises, it will propagate it immediately to all your cloud deployments. But what about if you want to have monitoring and logging and you don't want to have all these disparate elements together? Well, thankfully, Prometheus and Zabbix, they play very well together, and bonded with their rather native counterparts, Elastic and Grafana, working together, they form an unbeatable package solution that allows you to basically do everything, one system, 4 functions. But the biggest one I've seen a lot of recently is a lot of businesses having old colo setups, especially ones that were designed for data-intensive applications where they used a lot of compute and storage. But they've moved a lot of that to the cloud, but their public cloud is getting very expensive for their development as well as production, so they have to make a choice. Well, they've got a lot of tools, they've got a lot of materials on hand, and with a tool like OpenStack, bonded with Spinnaker, which actually, by the way, Netflix extensively uses, you can use what you already have, that compute-heavy infrastructure in your colo facility, and as soon as it's ready, you can use Spinnaker to send it to whichever cloud services you like, or all of them at once. Now, especially, I talked about earlier Tekton taking the cloud-native environment by storm. There's 2 ways we can use it. Remember I talked about GitOps being a central part of GitLabs, but let's say you don't want to put it up on the cloud for whatever reason. Don't trust it, don't like it, no problem. You can do everything that GitLabs does on your own premises, and still ensure the best practices by just simply using Tekton with Jenkins X. What about if I wanted to build a Kubernetes cluster and I wanted to make sure that when I put it up on the cloud, everything is as it should be, and not just testing, it's configured and orchestrated just as it needs to be? Well, OpenShift and run Tekton. Why? OpenShift was built with Tekton in mind, and it works excellently. One cluster, no problem. Now, on a personal side note, I actually had an idea about this, and I'm not sure if this works or not. But OpenShift with Tekton we already have said that integration is already present, and you can build Podman containers using the same commands. Considering OpenShift has this Docker support, I am curious to know whether I could take just my old Docker files and build Podman with them. And considering its capabilities, I think it might just work. But I think using just but it might need some aliasing to keep the commands straight. But other than that, I think it could be possible. So I, for myself, am looking at something like that in utilizing Tekton. So in summation, there's a place for everything, and everything has a place. By using this principle, we use a single, as I said earlier, a single methodology, regardless of whether it's going to be an on-premise or cloud-based. And that is best exemplified by using Jenkins. Jenkins in one kind or another. If you know Jenkins, you know how to deploy it, no matter how you're going to deploy it. You can use a single source of truth in Git, so you don't have to fiddle around, just use one. It works for everybody, it plays with everybody. And as I've said many times, same commands, I get different results. I use one command in Docker, I use another command in Podman. It doesn't matter where I'm going to put it in Kubernetes or run a swarm, it will work just so. Utilizing the same technology in different ways. Well, Kubernetes various flavors from OpenShift to Rancher to the original Google design. It's the same technology, but each one has a specific use that you can take advantage of. And you have tiered applications of using the same method. You can use infrastructure as code for simple things using Terraform, or if you got something complex, you don't have to use a different method. You can just use Pulumi. You might have to use a different code, but the concept is the same. And then you have the same underlying technology with different locations, because a little secret about the cloud industry, AWS and GCP built on a custom form of OpenStack. So if you build on OpenStack, it's native and compatible to your AWS and will probably behave the same way, almost exactly. And as I discussed with the monitoring tools, you can take several tools and package them together as a unified solution, and that being Zabbix, Prometheus, Grafana, and Elastic. Therefore, you can basically take these disparate elements and use them as a unified solution that just you can work with interchangeably, no matter whether it's historical or real time. And finally, the greatest element of DevOps and the greatest dream to be always for those of us who are having to code it, using declarative code from start to finish. You can go from Jenkins to Terraform into your production. Why is this so important? Because it's human readable and it's a lot simpler than having to sometimes write that programming code, which can be long and tedious, even though sometimes more capable, depending on your uses. And this idea that I'm talking about of utilizing same methodologies and technologies to maximize effect, I call the 3B, which is the three big bombers concept, and exemplified by two aircraft of the Cold War era, which is the B-52 and the Tu-95. Now, the B-52, for those of you who aren't up on your aviation history, it was a lone wolf nuclear bomber, but by the 1960s, it had grown out of date because of air defenses, and ICBMs were more capable of making that delivery. But those missiles couldn't be called back so easily if the situation were to change. But that missile technology, when bonded to the B-52 in the form of air-launched cruise missiles, with them also still carrying their original free-fall nuclear weapons, allowed the US Air Force to have a platform that could make two strikes with one plane, maximizing the deterrent effect. Now, the Soviets found something similar with the B-52. They built the aircraft to be a lone wolf nuclear penetrator, but they also decided to go for missile technology. But in seeking a new role, the Soviet Navy decided to use it to even up the odds for the Soviet Navy against America's carrier groups. By using those anti-ship cruise missiles, they were able to create the most capable maritime patrol and attack plane to ever face the NATO alliance. In fact, so profound was it that the United States actually designed a fighter to counter this very threat, and only this threat, and that was the famed F-14 Tomcat. So we're showing two sides of this very similar effect, combining new technologies with old older technologies to amplify its effect and keep it relevant, as well as using a technology in a way that it wasn't exactly intended, but still getting outstanding results. And you see that with Docker being this kind of replacement for virtual machines in rather confined space computing applications. Is there one tool, though, that just reigns above them all as the sun king of DevOps? Well, le système c'est moi, and that is Ansible. And it is because, well, all applications and systems can use it because of its utilization of secure shell. It can serve as a central hub because it has the ability to do simultaneous automation. And because it's built mostly in Python, it's usable on virtually any platform, from Windows to Linux. Even Mac can take advantage of it, as well as also various applications being able to use something like Python. How's its commands laid out? YAML playbooks. You can use them for networking configuration, application configuration, or you can even use it for security. Different context, but you're still using the same thing, at least in principle. And it's agentless, which makes it lightweight. You don't have to put a secondary application sensor on an already crowded container, cluster, or virtual machine, so it makes it simple to implement. Just make an SSH connection and you're good to go. And the final thing is it's idempotent. Now, this algebraic term, which was actually obscure to me until recently, means basically it only changes what needs to be changed. So if you make a change after the first time, it's probably going to be shorter and simpler. It only changes what needs to be changed, and it doesn't change anything else, which also reduces the chances of errors. But the most important thing of it, it has Ansible Galaxy, which is basically the GitHub of playbooks. Tons and tons of off-the-shelf code that you can use, so you don't have to spend time rewriting and reinventing the wheel, as it were. Instead, you can just use that off the shelf, and if you need to tailor it, no problem. In fact, it's welcome that you take your tailored code and put it up on Ansible Galaxy and help another user or company. Many do share their playbooks. Now, for the application of this idea, this constellation of automation, this is actually something that recently I was developing myself for a potential client in creating a containerized VoIP system that you could put in a small scale implementation. They didn't really have enough room really to put an extra blade in their server room, so I kind of thought something small like a Raspberry Pi or maybe as large as a NUC, an Intel NUC. Integrating OpenSIP so you have a session border controller, the Python-based PBX and call manager so you don't have to have that physical big board on your closet, on your telco closet anymore. You can just have it in this small little device that sits on your rack, saving space, and securing it with pfSense so you don't have to worry about the security being compromised in any way, and to make it easier for your session border controller to call out to your service provider, because firewalls are known to be very difficult for VoIP connections. And I thought to integrate this all using a Python module. But to keep it so that I could continue to improve its compatibility, I thought to start with Cisco devices and work my way to ShoreTel, MyTel devices, Avaya, what have you. I was going to need a continuous integration and delivery, as well as deployment for the various customers. So I thought, well, we'll use DevOps methodology to make sure that it's ever increasing its capability. So I designed it to be able to be written in Python. I'd use a Git server to keep my version control. And then when it was ready, use Jenkins to build the Docker file using the Docker plugin. Then take it using the Docker engine and putting it into the production system. And then on the production system, use Terraform to set up the infrastructure, to basically set up the infrastructure that it would be running on, and use Prometheus along with Grafana to monitor it and have that visualized data being put onto a network monitoring station or some other client that could be used by the network engineer to keep an eye on the system in case it got overloaded or the system became defective. But that's a lot of work, and that means it has to be constantly manned like the old school NOC. And while many people would accept this, and many businesses already have their own NOC, I kind of thought, well, could I automate all these elements so, it only required a minimal amount of human intervention? Well, I figured Ansible's how to do it. So using just a few YAML playbooks and maybe a few modifications to the modules, we could achieve a one-touch code to container on my end for development, as well as a self-deploying and self-healing container instance, utilizing Docker Swarm's abilities to basically make it so that it's set it and forget it. And basically give us a PBX SBC system that's virtualized, that automatically deploys itself, scales itself, fixes itself, and also updates itself with very little input from the engineer. Now, I'd like to point out that I'm basically using the Red Hat Ansible icon here, but it's probably advised, though, you might want to use this with Ansible Tower. So, but basically the idea here is we're just showing the methodology. So I would set it, and I could set it on 2 points of triggering the automation. I can set it at a git commit, or I can wait until I'm ready and tell Jenkins to call the Git repository to get the code before building. But I would probably put it on git commit. So as soon as I commit the code on my Git server, Ansible will tell Jenkins to immediately grab this code and build it and turn it into a Docker file and test it to make sure that it's functional before I send it off. Once it's in its environment, I would then use Ansible to basically call to Terraform to bond up with the Docker engine and put it into the production system and get it running. But also, I would set it so that the Prometheus, and also to tell it to spin up Prometheus and configure its agent to begin to watch the system's status. And it would continually report back to Ansible in the event that any unit in the cluster, in the swarm, I should say, became overloaded and defective. If it does, it will be discovered and it will be scaled up or that defective unit replaced before a serious failure can develop. And that would be by a simple Ansible playbook command to let it know. So with one tool used many times, I can get basically a handful of functions done for me with a handful of scripts. So I'd like to say that would be a very useful tool, and I think that would be great for especially small businesses without large IT departments, especially those that don't like to have engineers that sit on call all the time. And I know one or two companies in mind just off the top of my head that I can definitely say have already been interested in this. So we can do that, and we can do it quickly, efficiently, just by utilizing a place for everything and everything in its place with Ansible at the center of this solar system of DevOps. So any questions? Anybody have anything to ask?
Where are you looking for? Use the mouse. Right there. Oh.
Is everybody here, or did we lose everybody?
Oh, there we go.
No questions from the Fierce office, but you do have us. We had a demo cluster go down while you were presenting, Kevin, so I'm sorry.
Oh no!
Oh my God.
Oh well.
Yeah.
Murphy's Law.
Yeah. I think Kent's IM properly encapsulates that.
Just paying respects.
What's
But
up,
did
Ken?
y'all? Did y'all get like any much of the presentation?
I thought it was great, Kevin. A lot of our of course, Fierce's position is the enterprise support behind those upstream projects. I do appreciate the enterprise Ansible logo that you included, the red A there. I think that was the Red Hat logo.
It was.
Any questions from the crowd? I was holding off stopping recording just to see if we captured any questions, but I'm going to go ahead and stop recording here.
Okay.
Okay, stop recording.